Welcome to our tutorial about how we can use what we know about y equals mx plus b to solve problems. In this problem, we are told that a line has an x-intercept of 4 and a y-intercept of -5. We're asked to determine its equation. What we are being given are 2 points. We are given 4, 0 and 0, -5. We can use these points to determine the slope or the m value. We'll need to use our slope formula, y2 minus y1 over x2 minus x1, and we'll need to label both of the points. We'll substitute our values into our formula and simplify to get a slope of -5 over -4, or just 5 over 4. Now that we have our slope, we can put it into our y equals mx plus b equation. We will have y equals 5 over 4x plus b. We actually already know our b value in this problem because we were told that the y-intercept is -5. So we can substitute this also into our equation to say y equals 5 over 4x minus 5. We can conclude that the line that has an x-intercept of 4 and a y-intercept of -5 will have the equation y equals 5 over 4x minus 5. In this problem, we are told that a 5-item pizza costs $12 and that every topping costs 80 cents. We're asked to determine how much the pizza will cost without any toppings. We can recognize that we are given a point, 5 and 12, and we are given a slope or a rate of change of 80 cents per topping. We can put this into our y equals mx plus b. We've been given a y of 12, and we've been given an m of 80 cents. Our x value will be 5, and we will need to find b. B will represent the cost of the pizza without any toppings. We can simplify by multiplying the 80 cents by 5 to get $4, and then we can move this $4 to the other side of the equal sign so that we have 12 take away 4 equals b. This will leave us with 8 equals b. Since b represents the y-intercept or the initial value, we know that a pizza without any toppings will cost $8. In this problem, we're given a table to reflect the cost of going to a drive-in movie. We're asked to find the base cost of the car with just the driver. In the table, we are given 3 different points. We can pick 2 of these points to use to find the slope or the rate of change. After this, we'll be able to use the slope and one of those points to find our b value. We'll substitute the coordinates of our selected points into our formula, and we'll get $18.75 divided by 3, or $6.25 per passenger. Now we'll need to substitute the information that we know into y equals mx plus b in order to find the b value or the base cost of the car and the driver. We can use the first point of 2 and 24. This will mean that when we substitute it into y equals mx plus b, we will have 24 equals our m value, which is 6.25, times 2 plus b. As we simplify, we'll have 24 equals $12.50 plus b, and then we will eventually find that b is equal to $11.50. This means that the base cost for the car and the driver is $11.50. In this problem, we are told that a line is perpendicular to y equals -2x minus 6 and goes through the point 4, 10. We're asked to determine its equation. We know that perpendicular lines have negative reciprocal slopes. So if the original line has a slope of -2, our perpendicular line will have a slope of 1 over 2. We can use this slope and the point to find the b value. We'll substitute the information that we know into y equals mx plus b. Y will be 10, m will be 1 over 2, x will be 4, and we'll add b because that's what we are trying to find. As we simplify, we'll have 10 equals 2 plus b, or 10 minus 2 equals b, or 8 equals b. Now that we know the b value, we can put it together with our slope of 1/2, and we will have our equation of our line that is perpendicular to the line -2x minus 6 and goes through the point 4, 10 will be y equals 1/2 x plus 8. In this problem, we are told that Justin paid $25.50 for 6 sunflowers, and Jessica paid $39.25 for 11 sunflowers. We are asked to determine the cost of each sunflower and the vase they came in. This is asking us to determine both the rate of change, or m value, and the initial value, or b value. We'll begin by trying to find the rate of change, or the slope. We know that the problem is giving us 2 points, 6, $25.50 for Justin, and for Jessica, we have a point of 11, $39.25. We can use this as our x1, y1, and our x2, y2, and substitute it into our slope formula. This will help us to determine the cost per sunflower. Substituting and simplifying our slope formula tells us eventually that 5 sunflowers are going to cost $13.75, or that each sunflower is going to cost $2.75. We'll use this cost per sunflower along with one of our points in order to find out our b value. We will substitute the known information into y equals mx plus b. We can use the first point so that our y value will be $25.50. Our m value will be $2.75. Our x value will be 6, and we'll add b to the end so that we can determine its value. Multiplying 6 by $2.75 will give us $16.50. And when we subtract that from $25.50, we will get $9 for the cost of the vase. So we can conclude that the cost per sunflower is $2.75, and the cost of the vase that they come in is $9.